Okay, I wanted total deep research on all the projects that are currently about taking a document or a set of documents and using LLMs to build a graph. And in my particular use case, it's going to be super important to know what is public and private, because the particular system I'm building is navigating alignment between individuals. And since there's cross-leaking between entities here, you have to be strict in managing the privacy of data. While at the same time, you want to let the AI figure out how to coordinate alignment. So it's going to require this back and forth messaging between the entities. So, yeah, I've reduced much of this to a particular bottleneck in computer science, one that we've only been able to reason about since the births of LLMs, which is building graphs from this text, building graphs where we know the type of information we want to place in particular types of nodes. And when information is placed on this exact node, then we can be fairly confident about this. So if this is an alignment object, which is a type in the system, between two individuals, and it has as its property that is public and relevant between these two entities who are both connected to this node, to this alignment object between them in a graph, if we have this function that we're doing a research about in this presentation, then we can be reasonably confident that that linkage has happened correctly. And in practice, in these federated alignment protocols that I'm considering, you'll usually have some consent to confirm this. But you don't want to make a mistake. You want it to be seamless, and you want to iterate to the point where you could possibly do it without the human's supervision going to a form, basically. So I've asked AI here to compile a research report with all the GitHub projects, all the open source problem formulations and writings in academics and in research labs, to survey these and create a comprehensive report. And it's asked for some clarifying questions, which I've answered. Okay, so here's going to be my live reactions to the response. So the AI says that it's going to go off, do this deep research on open source projects, code bases, papers, and research groups working on parsing documents with LLMs into graph structures, using ontologies. Okay, so it begins. Large language models are increasingly being used to extract structured knowledge graphs from unstructured documents, combining the strengths of natural language understanding with formal knowledge representation. Traditional knowledge graphs store factual data with explicit relationships, offering interpretability and logical querying, but have been labor-intensive to build and update. LLMs, on the other hand, can read and summarize text flexibly, but often hallucinate facts or miss deep structure. Recent efforts aim to unite these approaches, using LLMs to parse text into graph structures, node/edges, aligned with ontologies or schemas. This enables capturing information as semantic triples, or ontology-aligned fields, subject, predicate, object statements, key value fact, etc., from any kind of document. Below, we present a comprehensive overview of open source projects, research labs, frameworks, funders, use cases, and emerging standards in this fast evolving area. So the motivation for this, according to AI, yeah. So why are we going to use LLMs to build out these knowledge graphs? Have LLMs, it has replaced the need for knowledge graphs in certain ways, but there's this critical use case of the control system, and that you don't just want to attach the AI willy-nilly to control systems, basically. You have to map the output of the artificial intelligence onto a knowledge graph, onto a control system that's going to govern things like what I'm interested in. The use case of the federated alignment protocol is, what are the objects, the alignment objects between us? What is the context that we want to expose to these alignment objects as we navigate communication and collaboration between individuals through artificial intelligences? So LLMs have revolutionized natural language processing with fluent text generation and broad knowledge, but they can be inconsistent or inaccurate on factual details. Knowledge graphs offer high-quality structured knowledge and reasoning, but are hard to construct and keep updated. By using LLMs to populate and maintain knowledge graphs from unstructured data, we can leverage the strengths of both. LLMs provide flexible understanding and extraction, while graphs provide a structured, queryable memory with improved factual grounding and interpretability. As one survey notes, general knowledge graph construction via sec-to-sec models is a flexible new paradigm for knowledge graphs. A recent roadmap by Penn categorizes efforts into 3 frameworks: knowledge graph enhanced LLMs, LLM augmented knowledge graphs, and synergized LLM plus knowledge graph systems that tightly integrate both. The overall vision is to have LLMs continuously read and convert text into graph structured knowledge that can be queried, reasoned over, and kept consistent over time. This has sparked dedicated forums like the KALLM workshop at ACL 2024, which highlights topics from knowledge graph creation with LLMs to privacy and multimodal applications. Okay. So there's a academic discipline to connect ourselves to in the making, because academic disciplines are often formed in these sort of workshops. People come together. And now there's going to be all kinds of material on this subject of building these control systems with AI, building knowledge graphs with AI, building alignment protocols that ground the conversations we have with artificial intelligence to the relevant set of alignment objects that exists between individuals as they seek collaboration on various enterprises. So there are several open source repositories that demonstrate how LLMs can be used to build knowledge graphs or structured representations from text. Many are active on GitHub, combining prompting techniques with graph databases or visualization tools. GraphGPT, Natural Language to Knowledge Graph, a popular demo that takes any text and generates an interactive graph of entities and relationships. It uses GPT-3 with a few shot prompt to output JSON representing nodes and edges, which are then visualized. Successive queries can update the graph state. Excellent. Okay. Nice. LLM Graph, a Python tool to create multi-hop knowledge graphs from a source document using LLM calls. Given a starting entity and text, it prompts ChatGPT to extract related entities and relations. Okay, great. So there are all these ones that we can look into a little bit more. And then prominent research labs and academic efforts. Academic and industry research groups are actively exploring LLM-driven semantic parsing and knowledge graph construction. Key contributions include survey papers, novel frameworks, and dedicated research lab projects. Okay, a seminal paper. Okay, so it's basically saying there's all this academic work also showing how to do this. So stuff to dig deeper into. And the frameworks have emerged to facilitate document to graph pipelines with LLMs. The popular LLM orchestration framework LangChain has built-in support for knowledge graphs. It provides a component called LLM Graph Transformer that converts text documents into structured graph documents by leveraging an LLM to parse and categorize entities and their relationships. Excellent. Developers can specify allowed node types or relationship types and ontology to constrain the extraction. LangChain also offers a conversation knowledge graph memory for agents as a chatbot runs. It can store facts as triples in a knowledge graph memory and retrieve them later for long-term consistency. Using LangChain, one can change steps like chunk a document, use an LLM to extract triples, and call a graph database client to upsert those triples. Well, this isn't revolutionary stuff. Yeah, it bottleneck really with the AI and the query and so on. And then it's about constructing the ontology that works, basically. The graph space that is relevant. And yeah, that's where the alignment problem comes in, and you know, there's there's this project that we're doing to test this. So we're going to be building these knowledge graphs according to ontologies for alignment and piping to AIs that are in these, listening on these federated systems. And we're going to try to reach alignment on questions like the project itself and adjacent entities that could be monetizable from this protocol. So yeah, if you're interested in being a collaborator on this project, you're welcome to reach out. If you're interested in having artificial intelligence that helps with alignment, whether it's for your clients or within your own ecosystem, and you want services for this integration, then please reach out also. And yeah, if you're just generally interested in this, you can continue to subscribe, or you can hit subscribe and continue to watch these videos where we're going to go into the computer science and the human aspects of alignment in creating an ontology and community for alignment on this. Okay, have a nice day.